Welcome to a new test and teardown video. Yeah, I'm playing with some more Brüel Kjær stuff. This one is a phase meter type 2971. So it looks like it's comparing two different input signals, and the difference in phase is displayed here. I think we can, I don't know if we can see this. No, we cannot. But there's one of those neon fluorescent displays, not a VFD, but it's just a neon 7-segment display, so it's probably going to glow really nice orange. So I really hope that will work. You can display in degree or radian, degrees, whatever scale. Read out, is that a reset for that? Or you could output 360 or 0. And there's also a little bit about frequency ranges, or limit the input range, I guess. Slope range. Okay, so we can invert. Okay, that's interesting. I look forward to try and see what happens here if we plug this. There's also an analog meter as well as a digital meter, I guess. It's probably active at the same time, right? The backside is really packed, and those are really nice small instruments, so obviously there's not so much space here on the back. We've got pen lift. Okay, so that is an external plotter. And to some external equipment, whatever that is, super secret. Output offset, and that will be a DC offset, probably for a pen writer. Power supply regulator, I guess. A digital output in some sort of I don't know what kind of format that is. I mean, let's just power it up and see what happens. Like that. So I think I set up everything. Should be able to turn on mains. Look at those super nice 7-segment displays. I mean, maybe I should put it down. And if everything here is in the middle. 20 Hertz, interesting. I will enable input and input. So now I got two inputs of exactly 1 kilohertz, and it should. Okay, so this is how I had the idea I could zero it. What is that doing? Ooh, that is cute. I mean, I'm just told. Okay, finally. No, okay. Here is the problem. Now, there's a loose connection here, right? So now we are happy. Let's see if the other one is just as buggy. Okay, so there's a good reason to open this and fix that connector, because if I touch this, okay, so it's fixed. All right. What is this doing then? I don't know what they do. So I'm going to play a little bit with the phase delay here. Let's input 1 degree phase difference, and then it goes crabbity crab again. I don't know. Hello. This thing is not good friends with me, really. So that is 1%. Okay, let's give it 10. Okay, so it actually seems to be working when there is a good connection with this 10, 21%, 30, 40. Okay, I mean let's go the other way and see if it's going. What I'm doing here, that's back to 0 and then minus 10. Okay, minus 11 is what I think I got. Anyway, the unit looks like it's working. We have to go in and see if we can fix this. Maybe it's just dirty or something. Oh yeah, look at that. It's all black in here, right? So that plug, well, it's, or is it? See, this good old stuff just need a little bit of massage. Look at that. Ooh. So there's a microphone in there. Or just a loose connection, right? Yeah. Let me have a look. Let's have a look inside here. It's actually packed quite a lot. I didn't expect it to be that complicated. So if this is up, oh, look at all that stuff. That's definitely display driving. Power supply. Let's get a little bit more light in here. So yeah, well, that's the display. High voltage, 7-segment nixie kind of style neon segments. So yeah, they are running on high voltage. So when you play with stuff like this, don't poke your fingers around here. This is not a good idea. And we'll also see neon bulbs as well here, so definitely this reveals the age. So this is 70s kind of style. I really like the copper bar for the digital power supply. That is really cute, but is that really necessary? This is a 2-layer PCB, and they're all already using both sides for all the signals and good stuff. So yeah, they wanted to add a third dimension to that. Here we got power supply regulators, and there's a trimmer there, probably some voltage supply, and there's an op amp down here. Oh yeah, that's a Zener diode or something, right? So that's probably power supply. And that bottom PCB contains some, yeah, all the analog stuff, and a relay, a very big one. So what is that doing? We got some more analog stuff here, and again, good power supply rail here. So yeah, I'm looking for a loose connection. I think I'll power it up again and play a little bit more with this and see if I can find a loose connection. But definitely it's super easy to change the two BNC connectors, and that is probably where most of the problems is. I could just try and attach my signals directly to the wire here and see if it's now performing more stable. But I'm going to play with this for the next few hours and see if I can make this super good again. Oh, look at that. The layout around that one. That's quite cute. This is also old style PCB layout, and it looks like machine soldering and then hand soldering some wires and stuff. And if we look inside, you'll see all the wires. And that's of course all the hand solderings. Nicely tidy. Good clean product. We got a connector for the display, but that doesn't really explain all the loose connections. I don't see any other connectors or intercon between the different PCBs or anything. It's cables and they're soldered in. So that means this unit is just good and stable. There isn't really any good explained for loose connections here. Meanwhile, I figured out how to adjust this meter. I found out that one is the 0. So when I input 0 degrees, I adjust that one for 0, and then I input 180, and then I adjust that one for 180, and then it goes accurate no matter what. So that is great. But so far I haven't figured out exactly about this loose connection. It is definitely not in the connector here, and I tried to poke around in the different switches, and it's not a switch kind of thing. But look at that. See, that is the left side. Ooh, and I try to hit it exactly the same. So is it at the back? Of course, if I hit it real hard over here, yeah, see? But I need to hit it quite a lot more here. So I guess it's not that PCB, but my idea is to loosen the screws of the PCB so it's not touching the frame, and then see if I can recreate this. And there's another kind of funny thing is when I hammer the PCB this way, it's not happening. It's only a kind of down. This can't be good. Where the heck is that problem? I would love to figure out how to solve that, because it's not supposed to do that, right? Poking around with this loose connections for quite a while. See, I've been removing screws from the PCB here and then hammering on the case. Didn't change anything at all. Okay, so I took the other PCB out, and again I put it on something soft, and see, now I can hammer as hard as I want on that PCB. So that is definitely not the problem, but it's still super crazy, right? So there's a relay down here, so I took out the relay and then I just booted up the unit, and obviously this relay is not in use for some reason right now, at least, so that is not the case. And then I figured out, okay, so there's another board on the bottom. How about that? And then I've been trying to hammer around on that board, and it doesn't really seem to be that critical. And then I started to hammer on the back side. Ooh, super sensitive. So look what I found. The green wire. If I touch the green wire, only the green wire. Here's actually more. Actually, it's disconnecting the power supply. So it's not the blue one. No, not the other ones. This is, by the way, mains voltage selector. So I need to be very, very careful about what I am doing here, because it could easily blow up in my face. Well, that green wire is definitely the thing that is causing all the problems. And so I need to disassemble this entire contact and figure out what is going on with that one. Not that easy. So that was something. It was adjusted for 220, and the way that it works is the fuse is actually one of the contacts that goes into the center pin. That will be the gray, and that is completely good and stable. So then it goes from the gray and only to the green one, right? So this is our mains supply, I mean, it's impossible to have a bad connection out here. Look at that, is good. So it's that end here that touches a spring kind of contact right here. Look at that. It looks like it should be able to grab on this piece of metal from top and bottom, but it's not doing that. It's quite open. So I need to try and see if I can bend this back so it's going to be a good, firm, stable connection. And that will be my fix. After a little bit of cleaning and reassembly, I don't know if you can see this. Ha ha ha. And now I can... Haha. We got a nice stable instrument. And I can close this video and say thank you very much. See you tomorrow.